Welcome back. In this video, I want to give you a brief introduction to object-oriented programming and how we can use it to create classes for feature engineering. Throughout the development of our machine learning pipeline, we've used code that learns and then transforms the data, or learns and then predicts something from the data. So in the different steps of the machine learning pipeline, we learn parameters from the data, and then we use those parameters to either make transformations or to output predictions. When we did the feature engineering manually, we were in essence using procedural programming. In procedural programming, we have code with procedures to learn the parameters from data and then to make transformations or predictions using these parameters. We also have data that stores these parameters, like mean values for imputation or the regression coefficients for the lasso regression model. We've noticed as well that in order to transform new data, we had to hard code a lot of the parameters that we learned throughout the pipeline. And we also had to save multiple objects or data structures as we went along. So procedural programming may seem straightforward, but it has its shortcomings. In object-oriented programming, we write code in the form of objects. And these objects can store data and can also store instructions or procedures, the code, to modify the data or to do something else, like obtain predictions from the data. The data is stored in what is called the attributes or the properties of the object or the class, and the code or instructions is stored in what we call the methods or the procedures of the class. So the beauty of object-oriented programming is that we have all together in one object both the functions to learn and modify the data and the parameters, so the data that is going to be used to make those transformations. So as I said, in object-oriented programming, the objects can learn and store the parameters. When we use objects instead of procedural programming, the parameters get automatically refreshed every time we rerun the code or that we retrain a model. So there is no need to hard code values anymore. We're going to create objects that contain the methods feed and transform, and in the method feed we're going to include code to learn parameters from data, and in the method transform we're going to include code to transform data using the parameters learn. And these parameters are going to be stored in what are called the attributes of the class. So how do we create a class using Python? This is very straightforward. We just need to use class and then give a name to the class that we want to create, and it's usually using capitals. Most classes take an init method, and this init method contains the properties or the parameters that the class takes whenever it is initialized. The first parameter of the init method is always self, and then it can take as many parameters as we want. So in this particular example, we create an initialization method that takes self and then variables. So then we assign variables to the class, so to the self. So these variables is the parameter that I'm going to give to the min imputer whenever I initialize the class. So for example, once this class is ready, if I call my imputer equals min imputer, in the variables I can pass a list of the variables that I want to impute with the min, for example. So if I then go ahead and execute my imputer.variables, I'm going to see that the argument of that attribute is the variables that I used to initialize the class. The methods in the class are defined as if they were functions with the term def. The methods are the functions, as I said, defined inside the class and can only be called from within that class. The first parameter of the method is always going to be self, and then I can pass as many parameters as I want. Our method feed is going to contain code to learn parameters from data whenever that is necessary. And in order to be compatible with the Scikit-Learn pipeline, we need to pass a data frame X and the option to pass also the target. So in this bit of code that we see here, we are taking the data frame that we pass as argument of fit, and for the variables that we use to initialize the transformer, we want to take the mean value and then convert it to the dictionary, and this dictionary is stored in the imputer_dig attribute of the class. And it returns self because this particular method is not returning anything other than its own attribute. So if we then go ahead and initialize one class with the mean imputer passing 2 variables, and then we fit this to some data, when we execute the imputer dictionary, we're going to see that the mean value of the variable age is stored, as well as the mean value of the variable fair. We can go ahead and create now a transform method that will contain code to transform a dataset. So we define the method with def. To be compatible with Scikit-Learn, transform needs to take the data frame, and always the first argument is going to be self. And in this bit of code, what we are telling the class to do is for each variable in self.variables, so in the variables that we defined here, fill the missing values with the value learned and stored in the imputer_dig during the method fit for that particular variable. And in this case, we return a data frame. In the next video, we're going to introduce the concept of inheritance.